Hello everyone. This video is on the Knewton Alta assignment for section 6.3 called Multiplying Polynomials. In this video, I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video are not necessarily going to be the same questions that you see when you work on the assignment on your own. But the objectives are all the same, the structure should be similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so the assignment page, you should be seeing the title, the mastery bar that tells you how far along you've gotten, the objectives. It looks like there are 3 objectives. Under the current objective, you should see a question related to that objective. And then at the very bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button for instructors only. But you will have the more instruction button. So if you're ever struggling with a topic or a question, try clicking on this. It'll take you to a page with some reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to progress through the assignment. Alright, so the first objective I'm looking at is multiply a binomial by another binomial. Alright, so you have a product of 2 polynomials, and each of these polynomials, each of these factors, has 2 terms, right, as a binomial. It really doesn't matter if you have they have 3 different objectives here. A polynomial by a monomial, binomial by binomial, trinomial by binomial. It really doesn't matter what the size of the polynomials are. As long as you know how to use the distributive property and multiply monomials, right? If you remember back from section 6.2 on multiplying monomials, you can turn any problem where you're multiplying polynomials into just a bunch of products of monomials. We'll see that with this first example. So I'm going to be doing pretty much the same thing for every single one of these. So we have 2m plus 7n, right, the first polynomial, the first binomial, multiplied by, and then just m plus 7n, right, the second binomial. So as I was saying, right, it really doesn't matter what the size or how many terms each polynomial has. You can approach each one the same way, each product. So when multiplying 2 polynomials, you're going to basically just take one of them, so I'm putting this one in a box, and distribute. And you're just going to be doing a lot of distributing is the key here. So this polynomial in the box is multiplied by both terms, distribute it to both terms, all the terms of the other polynomial. So this is equal to, we have 2m plus 7n times the first term of the other polynomial, right, times m. Then we have plus, right, plus, and then again this polynomial in the box times the second term, so the quantity 2m plus 7n times 7n. Right, and then we just continue distributing, right? I still have scenarios here where I can use the distributive property. See here, there's now 2m plus 7n. Now I can take this times m, this m here, and distribute it to the 2m plus 7n. And do the same thing with the other term. Take this 7n and distribute to the 2m plus 7n. And what we end up with is just a sum of products of monomials. Here we'd have 2m times m plus and then 7n times m, right? That's what I get when I distribute the m there, plus, and then from here we have 2m times 7n, right? 2m times 7n plus, and then 7n times 7n. Right, so what you should, and this is the case for any product of polynomials. When you multiply two polynomials, you should eventually be able to get down to a sum of products of monomials. A sum of products of monomials. And that should be the case every single time. And if you go back to section 6.2's assignment, right, you should know how to multiply monomials. 2m times m would be 2 times m to the second, plus 7 times n would be 7, mn. You can write n times n or m times n. Usually they put the variables in alphabetical order in the product in a monomial. Plus, and then 2 times m plus, times 7n. 2 times 7 is 14, and then you have m times n, right? Just mn. Plus, and then finally here, 7n times 7n. 7 times 7 is 49. N times n would be n to the second. And of course, combine like terms, right? These two terms are like, right? These are like terms here. They both have m to the first and n to the first in their product. So I can combine these. And remember, when you combine like terms, you just add the coefficients, just add the numbers, and you keep the variables and powers the same way they were. All right, so finally we have 2m squared plus, and then 7mn plus 14mn would be 21mn. And then you have plus 49n squared. And that's it. None of these terms are like terms. Right. And there's your product. Totally simplified. But like I said, you're going to be using the distributive property a lot. And you keep using the distributive property until you get down to a sum of products of monomials. And then, of course, combine any like terms afterwards. So back on the assignment, I'll type in my final result there, which was 2 times m squared plus 21 times m times n plus 49 times n squared. And that should be good. Now, after you submit an answer, you'll be told if you're right or wrong, and then you'll be given some sort of answer explanation. Please read through the answer explanation just to make sure you understand why things were right or wrong. Now notice here they're going through this FOIL method. This is only used when you're multiplying two binomials. You do not have to use this method though, as you saw me do. Okay, I'm going to be just going through and doing the same procedure every single time for no matter whether we have two binomials or a binomial and a trinomial, whatever. I'm just going to be performing the distributive property. I'm just going to keep using the distributive property until I get a sum of products of monomials and then simplify after that. But yeah, so hopefully you can again read through the answer explanations and understand why something is correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, so moving on. So here we have multiplying a trinomial by a binomial. So you see here there's a binomial, d plus 4, multiplied by a trinomial, d squared plus 4d minus 6. Alright, so like I said, lots of distribution when multiplying polynomials. So yeah, we have a d plus 4 times d squared plus 4d minus 6. So just like I did in the last problem, right? You take one of these polynomials, I'll just take the d plus 4, and distribute to the other one. Right, so to the d squared, the 4d term, and the negative 6 term. Alright, so this is equal to, now this time I'll just put it on the right side, just so we keep distributing from the left, because it doesn't matter what order you put products in when you're multiplying real numbers. Real number multiplication is commutative. So this first term is, d squared times this d plus 4. Then we have plus, and then 4d times the d plus 4. Right, I'm distributing the one polynomial to all the terms of the other polynomial. And then we have a minus 6 times the quantity d plus 4. Right, and then again, I continue to distribute until I get a sum of products of monomials. So I'm distributing the d squared now over the d plus 4. This 4d over d plus 4. And don't forget the negative is actually part of the term, right? The negative is part of the coefficient. So I'm distributing negative 6 to d plus 4. And now we'll have the following. Now this time, instead of writing out the products of monomials, I'll just write out what the results are. D squared times d would be d to the third. D squared times 4 would be, positive 4d squared. Then after distributing the 4d over the d plus 4, we'd have positive, 4d times d would be 4d squared. 4d times 4 would be 16d, positive 16d. And then after distributing the negative 6 over the d plus 4, we'd have, negative 6 times d, that's negative 6d. Negative 6 times 4, positive 4, would be negative 24. And here we go, right? A big sum now, right? After all, you just use the distributive property until you get a big sum of monomials. Right? That's all this is, a big sum of monomials now. And then, of course, combine like terms. The d squared terms go together. So we have d cubed, and then 4d squared plus 4d squared is, positive 8d squared. And then these two terms have d to the first, so those will go together. Positive 16d minus 6d would be positive 10d. And then you have the minus 24 constant term on its own. And none of these terms are like, so this is as simplified as that product will get. But again, lots of distribution when you multiply polynomials. You just keep using the distributive property until you get a sum of monomials at the end, and then combine like terms. Alright, so the product of these two is d to the third and then plus 8d squared plus 10d minus 24. Great. So you see they did the other way around. They distributed the second polynomial over the terms of the first one. It doesn't matter. And then they distributed those terms over the three terms and they got the same terms, the sum of the same monomials I did, just in a different order. All right. They also do this vertical method here. I don't know, you can read about the vertical method. I'm not going to do that. All right. So you multiply a polynomial by a monomial. Right? So this one's even simpler. You just have a single term, distribute that single term over the other polynomial. So these should be pretty simple when you're multiplying by a monomial. Right, here's a monomial, 9x cubed, times, and then a trinomial, negative 10x squared, plus 4x, plus 3. And yeah, it's just very simple. Take one of the polynomials, this 9x cubed, and distribute it over the other one to all the terms of the other one. Now 9x cubed times negative 10x squared would be negative 90 x to the fifth Alright, and then 9x cubed times positive 4x would be positive 36 x to the fourth. And then 9x cubed times positive 3 would be positive 27 x cubed. And none of these terms are like. Can't add any of these together. So there you go. There's our product. And that's what I'll type here. So negative 90. Sorry, I dropped something. Negative 90 x to the fifth plus 36 x to the fourth plus 27x to the third, and that should be good. Great. Alright, next. So once again, trinomial by a binomial. Alright. So I'll write this out, work it out. And all I'm doing is a lot of distributive property. So here we have, n plus 3 times, there's your binomial, multiplied by, n squared plus 7n minus 2. And again, I'm going to go through and pick one of the polynomials. It doesn't matter which. Just pick one of them and distribute to the terms of the other one. Right. So I take the terms of the other one and multiply by this polynomial. So we have n squared, times this n plus 3, then plus 7n times this n plus 3, and then the negative 2 times the n plus 3. And now I'm distributing a bunch more, right? Distributing the n squared over the n plus 3, the 7n over the n plus 3, and again, don't forget the minuses, right? Negative 2 over the n plus 3. So in the first distribution here, we have n cubed plus 3n squared. Then here, distributing the 7n, we'd have positive 7n squared plus 21n. And then this last distribution of negative 2, we'd have negative 2n minus 6. And then we combine like terms. So there's no other n cubed terms, right? We have n cubed. There's positive 3n squared and positive 7n squared. Those would go together for to make positive 10n squared. And then we have positive 21n and negative 2n. Those are like, making a total of positive 19n. And then you have the constant term minus 6. And there we go. Alright, none of those terms are like, and that's it. So same steps every single time, just a lot of distribution until I get a sum of monomials, and then I combine like terms. So n cubed plus 10n squared plus 19n minus 6. Great. And again, you can do the read about the vertical method if you wish, but I'm not doing it. Alright, so again, you can use the FOIL method. Again, that's something I'm leaving for you to read about. I'm just going to do all the distributing here. So multiplying two binomials. So once again, I'll write this out. We have 2x plus 7v multiplied by x plus 2v. And then again, I just pick one of these. I usually just like taking the left polynomial and distribute over the terms of the right polynomial. So those terms of the right polynomial are going to be multiplied by this first polynomial. Right? So the first term, x, will be multiplied by the quantity 2x plus 7v. Then plus 2v, the second term in here, is going to be multiplied by this polynomial I'm distributing, the 2x plus 7v. And then we do more distribution, right? Now I'm distributing x over the 2x plus 7v, and then the 2v over 2x plus 7v, and we'll get a sum of monomials. X times 2x would be 2x squared. X times 7v would be positive, 7 vx, right? Usually alphabetical order. You can do vx or xv if you want, but usually they put things in alphabetical order. Then distributing the 2v, 2v times 2x would be 4xv or 4vx. And then 2v times 7v would be 14, positive 14v squared. And then we have a couple like terms, these terms with v and x in it. So I end up with 2x squared, and then combining the like terms, 7vx plus 4vx would be 11, positive 11vx. And then you have this v squared term, right, plus 14v squared. And this expression should be equivalent to the product of those two, right? And now one thing I've been not mentioning here is if you want to test it out, go ahead and replace x and v with some numbers, and you'll see the product of these two is the same as as what you get down here when you replace x and v with the same numbers. All right, so try it out. Replace x with 1 and v with 2 or something, and then do the same thing in the final expression. Replace x with 1 and v with 2 and simplify, and you'll see the number in the beginning should be the same as the number at the end, right, if they truly are equivalent. But I'll leave that to you to check out. Alright, so the product is 2x squared plus 11vx and then plus 14v squared. Great. Alright, and I'm doing more of the same. Alright, I'm doing the same procedure every single time here. Alright, now this one I'm just going to write out because, I'm just distributing the monomial, this negative 8x squared, over the trinomial, 6x cubed plus 3x minus 6. So the first term, negative 8x squared times 6x cubed would be negative 48 x to the 5th, right? And then negative 8x squared times positive 3x would be negative 24x cubed. And then negative 8x squared times negative 6 would be positive 48x squared. Oops, forgot to. Let me get to where I can actually write it. Positive 48x squared. All right. And that should be good. None of these terms are like, they don't go together. And I'm done. Yeah, that'll probably be the easiest of the objectives, is multiplying, by a monomial. Alright, so we got one more like that here. So I have negative 8ab cubed, right? There's a monomial, and I'm distributing over this polynomial with 4 terms here. So just multiplying every single one of those 4 terms by negative 8ab cubed. So negative 8ab cubed times a to the 5th, b to the 4th would be negative 8, a to the 6th, b to the 7th. Right? And again, I'm assuming you remember how to multiply your monomials by now. So negative 8, a to the 6th, b to the 7th for that first term. And then negative 8ab cubed times positive 6 a squared b would be negative 48 a cubed b to the 4th. Negative 48 a to the 3rd times b to the 4th. Right, then the next term, negative 8ab cubed times positive 3ab would be negative 24 a squared b to the 4th. So negative 24 a squared b to the 4th. And then finally, negative 8ab cubed times negative 6 would be positive 48ab cubed. Plus 48ab cubed. All right, Again, you should know how to multiply your monomials from section 6.2. Great. Alright. Alright, there's one more of these real quick. So again, taking this negative 6a times b to the fifth, this monomial, and distributing it over the 4 terms of this other polynomial in the parentheses here. Alright, so I'll just write them out. The first one will be negative 6, and then, a to the 4th, b to the 9th, right, adding the powers, right, using that product property for exponents. Then plus 12, a to the 3rd, b to the 6th, and then the next term, plus 30, positive 30, a squared, b to the 6th, and then finally plus 60, right, negative 6 times negative 10 there, plus 60, and then a b to the 5th. And that should be good. Yeah, distributing the monomial should be the simplest of these 3 objectives, in my opinion. Alright, now we're back to binomial by binomial. So once again, I'll write this out and just do a bunch of distributing until I get a sum of monomials. So 10u minus 8v multiplied by u plus v. Again, just pick one. I usually do the left one. Taking this left polynomial and distributing it to the terms of the right polynomial. So this is, u times the 10u minus 8v plus, and then v times the 10u minus 8v. And then we distribute the u, distribute the v, and we get the following terms, the following monomials. You'd have 10u squared minus 8uv plus 10uv, and then minus 8v squared. And then you got the 2 uv terms that go together. So we end up with 10u squared. Then negative 8uv plus 10uv would be positive 2uv. And then minus 8v squared. And none of these terms are like that is what I'm going to type in. Alright, so 10u squared plus 2uv minus 8v squared. Great. Alright. Alright, so this one I'm just going to talk out loud. There'd be an a squared term, a times a. And then you'd have a times 3b, which would be 3ab. But then you'd have negative 2b times a, which would be negative 2ab. So 3ab minus 2ab would be plus 1ab. And then finally you'd have negative 2b times 3b would be negative 6b squared. Right, so I typed it out, the final result after combining like terms, and you get a squared plus ab minus 6b squared. Right. Again, with some practice, it should be that quick for you. You can probably do it out loud like that on your own too. But I'd suggest, writing out the first several examples just to get used to how things work. Alright, then we should just have, we have these trinomial and binomial products left. Alright. So here, got a binomial, right, u minus 4, multiplied by a trinomial, u squared minus 10u minus 10. So again, I'm just taking this left polynomial and distributing it to the right, the terms on the right polynomial. So the terms on the right polynomial, you have u squared times this first polynomial times u minus 4, then minus 10u times u minus 4, and then minus 10 times u minus 4, right, every single one of those. And now I'm distributing those. Distribute the u squared, the negative 10u, and the negative 10. So here I'd get u cubed minus 4u squared. From the middle term, the middle product, I'd have negative 10u squared, and then plus 40u. And then from the last product, I have minus 10u, and then plus 40. And then combining like terms, I got some u squared terms and some u terms to put together. I end up with u cubed minus 14u squared plus 30u, and then plus 40. And there's your final result there. None of those terms are like. So u cubed minus 14u squared plus 30u plus 40. That should be good. Alright, I should have just one more of these with a binomial times a trinomial. Again, you've seen it every single time I'm doing a bunch of distribution, right? I'm distributing until I get a sum of monomials and then combine like terms. Alright, so one more problem here, where again I have a binomial times a trinomial. Got 6d minus 1 times 3d squared plus 2d minus 7. So I'm going to take again this, this binomial here and distribute it to the trinomial. All right. So that gives me 3d squared times the 6d minus 1 plus 2d times the 6d minus 1, and then minus 7 times the 6d minus 1. And now I'm distributing even more. 3d squared, distributing the 2d, distributing the negative 7. The first product here would be 18d cubed minus 3d squared. The second product we have plus 12d squared minus 2d. And then the last product we have minus 42d plus 7. And again, I got some d squared terms and some d terms that I can put together. So we end up finally with 18d cubed. Putting the d squared terms together, we'd have positive 9d squared. Putting the d terms together, we'd have minus 44d, and then plus 7. And none of these terms are like, so that's my final result, the final product. So we have 18d cubed plus 9d squared minus 44d plus 7. Great. So yeah, so again, I did the same thing every time. If you find another method that you like better that still works and is still valid, go ahead and use it. But I personally like just doing a lot of distributing when I multiply polynomials. All right, and then keep distributing until I get a sum of monomials and then combine any like terms if there are any. Alright, and that should be it for this preview version of this assignment. Alright, and like I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are all the same. The structure should be similar. So I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. And thank you very much for watching.